And welcome to a brand new lesson. This is how beyond numbers, where we learn maths the easy way. In this lesson, we are looking at addition and then subtraction of algebraic fractions. Specifically, we will limit ourselves to monomial denominators. Take your notepad, your pen, and then let's learn together. Now, when it comes to adding and then subtracting fractions, it's a little bit different as compared to multiplying and then dividing. Why? Because we need to find the common denominator before working it out. This common denominator is actually the LCM. And the LCM is the smallest expression that all the denominators can divide. How do we find it? There are just two steps. You first look for the LCM of the coefficients. Now the coefficients are just the numbers. To find the LCM of the coefficients, which would be the least common multiple of the numbers. Then for the variables, you take the highest power of every variable that appears in the denominator. What do we mean by this? If you have 4x and then 6x squared as the denominators of two algebraic fractions, then let's consider the numbers. So 4 and then 6. What is the lowest common multiple of 4 and then 6? So the lowest common multiple of 4 and 6, we all know, would be what? 24. But when it comes to the lowest common multiple of the variables, that is x squared and x, what you do is you take the highest power. So this has a power of 1, which you don't write, and then this has a power of 2. Hence, our LCM is then going to be that which has the highest power, which is x to the power 2. So now that we know how to find the LCM of our denominators, let's look at how we can actually add and subtract these algebraic fractions. So to solve, there are 3 steps we need to follow. First, you find the lowest common denominator. The lowest common denominator is obtained from the lowest common multiple. You then adjust your numerators, that is based on the numerators, that is based on the denominators you have, and then you combine and simplify. Let's take some examples so we see how these processes or these steps are used. For our first question we have here, it says 5 over 2a, then minus 1 over a. How do we go about it? So since our denominators are 2a and then a, we then look for the LCM. The LCM of 2a and a. Now we said the LCM, if you look at it carefully, we have 2 as the coefficient of this a, and then that of this is just 1. So for the number side, the LCM becomes 2. Then for the variable, we have what? A and then a. They all have the same powers. So we just take one of them. So 2a becomes our LCM. We write our 2a, and then we can now adjust our numerators. So 2a divides 2a how many times? Once. In other words, 2a divided by 2a gives us 1. The 1 multiplies this numerator here. So that is 1 times 5. Then minus 2a divided by a. That is 2a divided by a. We know this a cancels out this a. And that gives us a 2. So with our 2, we multiply it by what? The 1. That is the 1 from this numerator. We then combine and simplify. So we have 1 times 5, which gives us a 5. Then minus 2 times 1, which gives us a 2. All over 2a. Simplifying further, we have 5 minus 2, which is 3, all over 2a. As simple as that. See how very simple it is. So let's look at some more advanced examples. So what do we have here in our next example? It says 2 over x squared, then plus 3 over 5x. We need to find our LCM. There is 1 and then there is 5 over here. So the LCM of 1 and 5 we know to be what? 5. Then we come to the variables. There is x squared and there is x. So the variable with the highest power is the x squared. Hence our LCM becomes 5x squared. We then work on the numerators. So 5x squared divided by x squared, that is 5x squared divided by x squared. There is x squared here, and that cancels out what we have in the numerator. We'll be left with 5. So we put our 5 here, which will then multiply what we have here. So 5 times 2. Then plus, once again, we have 5x squared, and we divide it also by this denominator. You know this 5 cancels out this 5, and then one of the x's cancels out one of the x's. So they are left with just an x. So that x comes to multiply what we have as the numerator. Simplifying further, we have 5 times 2, which gives us a 10. Then plus x times 3, which gives us a 3x, all over 5x squared. Now, you realize that there is nothing left for us to simplify. We don't have anything to simplify. Hence, this becomes our final answer. You see, you can choose to write it as 3x plus 10 over 5x squared, and it's still correct. Now, what if the variables we have in the denominators are actually not the same? How do we work that out? So in this last example, you realize that our variables are not the same. We have 2 over 3x, then plus 5 over 2y. And for the numbers, we have 3 and then 2. The LCM of 3 and 2 is 6. So we put our 6 here. And since the variables are not the same, all we need to do is to make sure they are all present in our LCM. So our LCM becomes 6xy. That is all. Just as for the numbers, we multiply 3 by 2, give us 6. So it doesn't always work that way. We multiply x by y to give us xy. We have 6xy dividing 3x. 3 divides itself twice, and then the x here cancels out this x. Hence, we are left with what? 2y. So that 2y comes to multiply the numerator we have here, which is 2. Same applies to the second one. So we have 6xy divided by 2y. This 2 divides 6 thrice, and this y divides this y. Hence, we have 3x. The 3x comes to multiply this numerator, which is the 5. And that gives us 2y times 2, which is a 4y. Then 3x times 5 also gives us a 15x, all over 6xy. This becomes our final answer. Very simple. We would end this lesson here. In our subsequent lesson, we would actually look at how to add and subtract if the denominator is a binomial. So then I'll leave you with these exercises here. There are 5 for you to try, just to test your understanding on them. If there's any issue of concern, you can always let me know at the comment section, and I'll address that for you. This is how Beyond Numbers, where we learn maths the easy way. If this lesson was helpful, you can subscribe if you haven't, and if you so do wish, so that anytime I release a video, you'll be notified as well. Bye for now, and see you in our next lesson.